Okay, hello everyone. Welcome back to another explained example for our ME 280 differential equations class. Today we have this first order differential equation, y prime is equal to 5y plus e to the negative 2x times y to the negative 2 with the initial value of y as 0 equals to 2. We want to solve this differential equation. Okay, so first thing we're going to do, we're going to rewrite this in the standard form. And we can immediately see that this looks like a Bernoulli equation, right? So we have y prime plus some function times y equals some function times y to the n. If you remember, the standard form for the Bernoulli's equation looks like this. You have y prime plus p of x y equals q of x times y to the n. And if you compare these two, you can see here n is -2. And of course, p is -5, q is e to the negative 2x. But what we really need is just n. Okay, so n is -2. And we know that to solve the Bernoulli's equation, all you need to do is some substitution, some change of variables. Okay, so our new variable, our new unknown function, we can call that u or v. That is y to the 1 minus n. And here, n is -2, so v is y cubed. Okay, so we have v in terms of y, but what we want to do now is rewrite the differential equation in terms of v, because we know that will turn into something that's easier to solve. Okay, so I need y in terms of v. How do I do that? Well, I can just raise this y cubed to the power of 1/3, because that will give me y equals v to the 1/3. Okay, so this is the first thing we need, very important. Second thing we need to write our differential equation is y prime, right? So I need to take a derivative of this. That will be 1/3 v to the negative 2/3 times v prime. This v prime is sometimes forgotten. It's really important that you have this term here because you want to write a differential equation, right? So v is some function of x. We just don't know what function. Okay, so this is the second thing we need. Now that I have y and y prime, if we go back into our differential equation and plug that in, we can write this whole thing in terms of v and x instead of y and x. Okay, so let's do that. So first we have y prime. So we're going to plug in, we have y prime, which is 1/3 v to the negative 2/3 times v prime minus 5y, so minus 5v to the 1/3 equals e to the negative 2x times y to the negative 2, which is v to the negative 2/3. Okay. All right, so now this is our new ODE. And what's special about this? Let's see if we can simplify this a little bit. Well, I can see that I can divide both sides by v to the negative 2/3. Okay. Or basically, you can say it like this. We can say multiply by v to the positive 2/3. And what we get is 1/3 v to the negative 2 plus, sorry, 2/3, negative 2/3 plus 2/3. Okay, so that's just going to be 1. times v prime minus 5 v to the 1/3 plus 2/3 equals e to the negative 2x negative 2x times v to the negative 2/3 plus 2/3. Okay, and this is turning into a much simpler equation because this is all 0. This is 0. So v to the power of 0 is just 1. So we get 1/3 v prime minus 5v, right? Because this says 1/3 plus 2/3 is 1. Equals e to the negative 2x, because this is, again, just 1. Okay? And you can also we can simplify this a little bit more. We can write this as v prime. If I multiply by a 3, you can write it like this. Okay, so now let's look at this differential equation. What's happening here? Okay, so this is, now if you look at this closely, this is a linear equation. First order linear differential equation. Okay, we got disconnected for a second, but hopefully you can see this now. So last thing we did was just rewrite this differential equation in terms of v, and now we have a linear equation. Okay, the linear equation has p of x. If you remember the standard form of linear equations, this p is negative 15, right? So how did we solve linear equations? We learned that in chapter 2 in the first few weeks. You just need to find the integrating factor, mu, just e to the px dx. And in this case, that's just e to the negative 15x. Right? And we just need to multiply through by this mu of x, multiply all terms by the mu that we just found, and we're going to get on the left hand side, if we've done this correctly, we should get the perfect derivative d of v times e to the negative 15x dx. And on the right hand side, we have 3 times e to the negative 2x times e to the negative 15x, and that's just 3e to the negative 17x. Okay, again, if this step is unclear to you, just go back and review linear differential equations from chapter 2. Okay, and now, well, we know we have a separable equation. I can just take the dx to this side, integrate the left-hand side, right-hand side. Integrating the left-hand side gives me ve to the negative 15x, and the right-hand side, negative 3 over 17 e to the negative 17x. Okay, so we're almost done because we are about to find v. And once we have v, it's not that hard to find y, right? So if I multiply both sides by the e to the positive 15x, I get e to the 0 on the left-hand side, which is 1, and negative 3 over 17 e to the negative 2x on the right-hand side. Okay. So we're on. I did make a mistake, and this is something that I'm glad I made this mistake, because it's important that we don't forget we need to have a constant of integration here. That's why we have the initial value, right? So here I need a plus c when I do this integration. Okay, so now v is, again, multiply by the e to the 15x, and you get negative 3 over 17 e to the negative 2x plus ce to the 15x. And this is our v in terms of x. Okay? All right, now that we have v, all we need to do is remember that v was y cubed, right? If you go back, v is equal to y cubed. So we basically back substitute and we get y cubed is equal to this. Okay, so we are basically done. We have y in terms of x, right? You can, of course, multiply, or sorry, take the 1/3 power of this to get just y. But how do we find the constant c? We go back to our initial value, okay? So initial value was y at 0 has to be equal to 2. So if I plug in 0 and 2, I get 8 equals -3/17 e to the 0 plus c e to the 0. And this will give me c is, let me move this a little bit. Okay. So c is, this is 1. This is 1. So c is just 8 plus 3/17. And that is, I think, 139/17. So we have found c, and we are basically done. We can now say y cubed is -3/17 e to the -2x plus 139/17 e to the 15x. And this is our solution. And again, as I mentioned, you can also say that y is this whole thing to the power of 1/3. And we are done. Right, so we found the unknown function y in terms of x using the substitution method. Okay, so very important example. This whole section of Bernoulli's equation, it's a little bit of work because you have to do the substitution to get a linear equation, and then you have to solve the linear equation, and then you do the back substitution. Those are the main 3 steps. So it's easy to make a mistake in one of those steps, like forgetting the constant of integration. So make sure to do many, as many as you can, many practices on this Bernoulli equation, and let me know if you have any questions. Thank you.